In this video, we're going to be talking about the exam mod 6. And now you are going to be taking exam mod 6 if you are a non-CCP student. So if you're a CCP student, there is an exam mod 6 bonus you can do. And so feel free to watch this because mod 6 is going to be on the final exam, but you're not required to do this particular lesson. So our first example says, suppose a rock lake falls into a lake. Its speed in meters per second is t seconds after hitting the surface of the water is given by S of t. We're going to round our answers to the nearest meter per second. It says, how fast is the rock traveling when it hits the surface of the water? Well, that would be at time 0 is when it hits the surface, because remember, t is how many seconds, or the speed in meters per second after hitting the surface. So it hits the surface at time 0. So if we plug in 0, we get 238 divided by 7. Now it says, how fast is the rock sinking 7 seconds after hitting the surface of the water? So that would be time at 7. So we're going to do 238 plus 40 times 7. Now it says to round to the nearest whole meter per second. So if this answer is not a whole number, I will actually I'll write down on my paper what it says, and then I will round it. So if you notice, if I plug 7 into my function, 238 plus 40 times 7, divided by 7 plus 8 times 7, I get 8.2222. See that? So if I want to round it as they've said, I am going to take, and I'm just going to put in 8. Okay? And then it says that the trend predicted by the function continues indefinitely. What value will the rock's speed approach? So over time, if this lake doesn't really have a bottom that we have to worry about, if it's just sinking and sinking and sinking, that's really the end behavior. What is it happening over the long term? So if we look at the function, we are really thinking about the 40t and the 8t, and that reduces down to be 5. So that is what we do when the top degree and the bottom degree of our fraction match. So that's why the answer is 5. So that is question number 1. That's a good question too. So we've got the same question. How fast is the rock traveling when it hits the surface of the water? Remember, that's just at time 0. So if you plugged in 0, you get 272 divided by 8, which is an exact 34. So you can put 34 now or leave it. How fast is the rock sinking after 9 seconds? We did this one before. We're going to do 272 plus 3 times 9 divided by 8. And I'm going to put the top and the bottom in parentheses, plus 3 times 9. So you'll see there my top and bottom are clearly defined, and I replace the t with 9. Now, rounded to the nearest second, meters per second, that 8.5, I'm going to round it up to 9. Okay. And if the trend continues, 3t divided by 3t, as those get very large, it just goes to 1. So first and second question are very similar. Now, this one says, suppose that the number of students at a college who have COVID-19 T weeks after returning to campus is given by that function. We're going to round our answer to the nearest student, so the nearest whole number again. How many students return to campus with COVID-19? So it says, remember, it says suppose that the number of students at the college who have COVID-19 T weeks after returning to campus is given by that. So at time 0, that's what they're looking for here. So 243 divided by 9 is an exact 27 students. How many returned after 7 weeks? We're just going to plug in 7, look what it says, and then we'll round out to the nearest value. So you can see we've got our top and bottom in clear parentheses. I put my 7 squared. Again, you can use that little yellow box if you want to, make it look more mathematical. Now I'm going to write down what it says. It says 1676.695. I need to round that to the nearest student, so the nearest whole number. So I'm going to put 1677. So I'm going to delete what I got, and I'm going to put in 1677. If the trend predicted, what value will the number of students who have COVID-19 approach? Well, what's interesting is over the long term, since our highest power is in our denominator, that always reflects that in the very, very long term, it actually is heading to 0. So let's check those out. So that is one where we have a higher power in our denominator. Let's look at question 4. Another similar to 3, so we're just going to go through this process pretty quickly. How many students returned to the campus with COVID-19? So we're going to put in 0, and so that would just be 36 divided by 2, which is 18. Now you can put 36 over 2. How many COVID students returned after 7 weeks? So I'm going to put that into now you can put it into your calculator too, but I'm going to put it into my iMath calculator so I can see what it says. So I'm just replacing my t with 7. And I have my top and bottom. Everything is clearly defined as if I would replace the t with 7. It looks good. And the preview, I'm going to write that number down. That is, so rounded to the nearest whole student. We're going to have to round that to 2,550. And then if this predicts, indefinitely, what happens if, again, our highest power is in our denominator, it's always going to head to 0. Now let's take a look at this one. Excuse me. Kevin has 19 coins and a combination of quarters and pennies. The coins have a combined value of $1.63. So this is an example of a system of equations. So we're going to call P the number of pennies we have, Q the number of quarters we have, and you're going to get 2 equations. Our first equation is going to be how many coins we have. We have 19 coins. But then we need an equation about their value. A penny is worth 1 cent. A quarter is worth 25 cents. And they totaled up $1.63. Sorry if I could write it right. Now, my bottom equation, I don't like the fact that it's counting by cents, dollars. So I'm going to multiply everything on that equation through by 100. It'll move the decimal places. I won't have to worry anymore about, I won't have to worry about that. Okay. So I'm going to leave my top equations good. But let's multiply the bottom equation by 100. We're going to get 1p. We're going to get 25 q's. And we're going to get 163. That just moves that decimal place 2 places if you multiply through by 100. Now, this is a perfect one to use elimination on. Let's multiply this bottom equation by -1. Okay. So our top equation, I'm going to leave alone. Our bottom equation, I'm going to multiply everything through by -1. And I'll add those 2 together. So the p's are going to eliminate. That's why it's called elimination. So that's gone. And then we get -24q equals -144. And then 144 divided by 24, the negatives would cancel, and we would get that we have 6 quarters. Now we had 19 coins altogether, so P plus 6 has to equal 19. So our number of pennies would have to be 13. And then just think to yourself, if you have 6 quarters, that's $1.50. If you have 13 pennies, that's 13 cents. And that total is $1.60. Okay. So it says write an equation that models the number of coins. So that's my first equation. They did use P and Q, so if they use different variables, please use different variables. But P plus Q equals 19 is about how many total coins we have. And then the equation for the values was the one I wrote, where 0.01 times the pennies plus 0.25 times the quarters equals $1.63. Let's just check, make sure those are good. So now it says how many pennies and how many quarters does Kevin have? Well, we found that the pennies were 13 and the quarters were 6. So that is a money one. So those are pretty kind of logical. I mean, you can just kind of write out a chart, but I think that's the easiest way to do it, is like I just showed you. Let's take a look at this one. Okay, so John is taking out student loans from 2 banks. The first offers 3.5% APR compounded annually. The second bank is 9% APR compounded annually. John took out a combined total of $12,000 in loans, and the total interest for the first year was $568.50. Let X represent the amount of money loaned in 30.5.5%, and Y represent the amount loaned at 9%. What is the equation that models the total amount loaned? That's our first equation. So I know that X plus Y had to total up to the $12,000 in loan. Kind of like we had 19 coins in the last one. Here we have $12,000 to invest. And then here we have about interest. Okay, so if we take our X equation, that's 0.35X. If we have our Y equation, that's 0.09Y. That total of interest is 568.50. So let's put that in. 0.035X plus 0.09Y. Just move those decimals over to make them a percentage. From a percentage to a decimal, move it 2 places to the left. Equals a total of 565.50. Let's check those. You always want to check your equation. Now on the test you can't, but I'll check it. What did I? 568.50. Sorry about that. 568.50. 568.50. Okay. So now it says solve the system. Well, it's just a system of equations, just like our last system. I also don't like the fact we've got those 2 decimal places, actually 3. So we're going to multiply this time by 1,000. I'm going to move it 3 places over. So we get our first equation is going to stay. And then we get 35X plus 9Y, 90Y equals 568. I keep writing that wrong. I'm sorry, 568,500. So I've moved all the decimal places 3 to the right. Now, all of those are divisible by 5. So my top equation is still okay. If we multiply these by 5, divide by 5. I'm just trying to get the simplest equation I possibly can. 90 divided by 5 is 18. And then 568,500 divided by 5 is 113,700. Okay, so now we have 2 much nicer equations. I mean, they're still pretty gross. I'm going to multiply this top one through by -7. Okay, So if I multiply the top by negative 7, I get negative 7x minus 7y. And then 12,000 times negative 7 is negative 84,000. Okay, so now I can use elimination. I'm ready to just add those two together. So the x's go away. 18 minus 7 is 11y. And 84,000 minus, or negative 84,000 plus 11, or 113,700 is 29,700. And let's hope that's divisible by 11. It is. That's a good sign that we haven't made a weird mistake, because you know how good I am at that. And then we know that they have to add up to 12,000. So we know that x plus 2,700 has to equal 12,000. So if I subtract 2,700 from 12,000, I get 9,300. So my 3.5% loan was my x, so that's 9,300. My 9% loan was the 2,700. Remember, those should add up to 12,000. They do. If you calculate the interest, you should get that $568.50. So there you go with that. And now we just have a system of equations. You can use substitution or elimination for these. One thing I notice is my bottom equation. All of these are divisible by 3. So why not make them as simple as you can before you proceed? Similarly, when I had those decimals, I multiplied through by 100, 1,000, whatever it was, to make it nice. Well, if you divide by 3 everything there, what do we get? We get 2x minus y equals 14. Okay, so now we have two very nice equations, really good to use probably elimination on. Let's multiply this equation through by 5, because then I will make this a positive 5 and a negative 5. Okay. Now when we do that, we get 10x minus 5y equals 70. So we get, let's see, we get that 14x equals 140, so x is 10. And then if we plug in to any equation, I think this is a nice one, why not? We get 2x's, which is 20, minus y equals 14. So y will have to equal 6. So there's only one solution here. If we eliminated something and we ended up getting like 0 equals 0, that would be an infinite number of solutions. If we used elimination and we got some nonsense like 2 equals 4, that would be a no solution. But we got one exact point, so I think we want a point, the point form. So I'm going to put in 10, 6, and I'm going to see if iMath appreciates that or not. It liked it, and we're good. Okay. Let's do another one. Now, I always check to see, can I reduce my functions? My top equation, there's nothing that's divisible in 5 and 9, so we can't reduce that down. But my bottom equation, I believe that everything is divisible by 4. Let's see here. Yeah, so we can divide that by 4. If we divide our 20x plus 36y equals negative 448, if we take that, because I want to make it as simple as possible before I start mushing things together, I'm going to divide this entire equation through by 4. Now what happens is something kind of interesting. We get 5x plus 9y equals negative 112. That was our original equation. And then we get 5x plus 9y equals negative 112 again. When they are duplicates, and you found it out, because otherwise you'd find that out earlier, you'd get 0 equals 0. That is an example where there's an infinite number of solutions. Let's look at question 9. Now in question 9, it says solve the system. My top equation is good to go. I don't think there's anything that I can change about it. It's great, yay. My bottom equation, I notice that we can't do much. 87, I was hoping, oh yeah, wait, we can. Okay, we can divide everything through by 3. I was thinking, is 87 divisible by 3? And it is. So I am going to keep going. Okay, so when I do that, I'm not touching currently my top equation. But if I divide everything by 3, I get negative 6x minus y equals negative 27. I'm sorry, that's not correct. 87 divided by 3. Oh, it's 29. I'm sorry, 29. Okay, so when it's a perfect setup for elimination. When we go to add those two together, this is the nonsense type I was talking about. I get something that is not true. 0 is not equal to 1. 0 will never be equal to 1. So that's where we say no solution. Those lines are actually parallel. They will never cross. To solve the systems of equations, you're looking for where the lines meet. They're not going to meet. And so there you go. Okay. And then our last problem is a rational equation we're going to solve. Let's start with our first one. Now I'm going to write it down, and then I'll expand my page so you can see it a little better, okay? Okay, so we've got this equation, and we want to solve it for x. Now remember, x minus 3 is not allowed to equal 0. That's our denominator can't equal 0 or it messes it all up. So remember, we can't get a value of 3. So that would be an excluded value if we go to solve it. Okay, so now how should we proceed? Put anything with more than one term in parentheses. Surround the entire equation by big parentheses or brackets or something like that. We need to multiply through by the least common multiple of all the denominators we see. Well, what do I see? I see a 5 and I see an x minus 3. So I need to multiply through that. Now remember, this is technically over 1. So the bottoms are just multiplied by 1. Okay, so the 1 is the only thing. So the bottom doesn't, nothing changes. But this 5 times x minus 3 is what we're going to multiply each of the tops by. Now, if I multiply this first fraction by this, what you'll find are the 5's cancel out, but we would be left with a 2 and an x minus 3. Now, let's do it again for each piece. In this piece, the x minus 3's cancel out. We are left with a 5 and an x minus 12. In this last piece here, if we multiply through here, the 5's cancel out. We are left with a 4 and an x minus 3. Okay, so now it's just an algebraic equation to solve. Just make sure we can't get a value of 3. Okay, so we would get 2x minus 6 plus 5x minus 16 equals 4x minus 12. Simplify each side down as much as you can. And I notice I get 7x minus 66 equals 4x minus 12. Now let's get our x's to one side, numbers to the other. So I'm going to subtract 4x from both sides. I'm going to add 66. Well, if I subtract 4x from 7x, I'm left with 3x on the left. And then a negative 12 plus 66, that is a plus there, is the same as 54. Now, 54 is divisible by 3. So if we divide off the 3, we get an answer of 18. That is not the answer that we were concerned about. 3 was the only answer we're concerned about. So that is our answer. There you go. Okay. Now let's do the last part of this. And then I want you to work on the bonus or any other assignments. Please use up your late passes because we are done with iMath after this. Okay, anyway, so our last equation, let me write it down. I am going to surround all of my multi-terms, numerators or denominators with parentheses. The only denominators I see are a 7 and an x plus 1. Remember that x plus 1 is not allowed to equal 0, so x is not allowed to equal negative 1. Okay, so we're going to multiply this by x plus 1 and 7. Now the x plus 1s are going to cancel. We're going to be left with a 7x. We're going to do it again. We're going to multiply that. The 7s are going to cancel. We're left with a positive 3 and an x plus 1. Here, the x plus 1s are going to cancel. We're left with a 7 and an x minus 6. So let's use our distributive property. Let's simplify each side as much as possible until we can't simplify any further. So that's what you see right here. 10x plus 3 equals 7x minus 42. And now it's just a matter of solving. So let's subtract 7x from both sides and subtract 3. When we do that, we are left with 3x equals, let's see, negative 45. And negative 45 divided by 3 is negative 15. That is not the solution we were worried about was negative 1, but negative 15 is good to go. So that's your exam mod 6 review. You will have your exam mod 6 test on the 12th. You need to work on the bonus assignment and any makeup work you need for the next few days. There you go.